this zero, there's a zero that has no explanation. And I'm going to tell you my understanding of it, and people may, who watch this from other countries or whatever, may disagree. But you can write, if I have 0.40, you can write it like that. Or let's say 0.0040. What is that number? Read it to me. Don't say 0.0040. Read it to me as an actual value. What would that be? 40, I'll give you a hint, 40 something. Yes, anybody?
40, 10,000.
Yeah, 40 10,000ths, right? Now, if I wrote, how many significant figures are there? This is a review 1, test 3, for those of you who are just joining us at home 2 days from now. Yes?
3?
No.
4.
No.
5.
Yeah. Yeah, just 2. Now. Turn to page, all right? We've done significant figures by instrumentation. Let's just look at significant figures in terms of rules, okay? You know what, I hate these rules. But I would write these rules in your notes, use these on your tests, okay? These rules, and the reason I don't like to use the rules is because it's just brain dead. You know, you're just using rules to identify significant figures, but you lose the message that the significant figures are actually coming from instruments. So let's just look at the rules and identify the significant figures that are there. I'll put a check over the significant figures. I'll put several problems on the board. This will be A, B, C, D. Is that all right? You with me? Okay, and we'll go through the six rules, and when the rules satisfy a significant figure, we'll put a check over it, okay? In black. Clear? And then when we're done, if I have to add a rule because of how we did things in here, then we'll add a rule, and then we're finished. Clear? Okay. Every non-zero digit is significant. That's rule number 1. Is everybody clear on what a non-zero digit is? Yeah? How many digits are there? Yes? What is it? No. Aren't there 10 digits, right? The non-zero ones are always significant. Okay, so far, that's rule 1, right? Is there anybody who doesn't understand that? Yes or no? Okay. Zeros appearing between non-zero numbers are significant. If you have a non-zero number and you have zeros between, significant. Is there anyone who has a hard time with that? Yes. Like you have 404. Careful. So, right? Clear? Yes? Okay. Let's put a little bit of an addendum on number 2. Okay? It says zeros between non-zero digits. Okay? Let's put zeros between identified significant digits are significant. Right? So if we have this, remember this? Isn't that significant? Right? Isn't that significant?
Yeah.
So what would be significant? The sandwiched zeros. I like the way you said that. So instead of saying zeros between non-zero digits are significant, we'll say zeros between identified significant figures. Is that a little easier? Yeah. It's not easier? You don't like that? Why not?
I like the other one better.
What is it?
I like the other one better.
Yeah, and the other one is good, but this is in addition to that. So in other words, if I have this, right? Right? According to the first rule, that and that are significant, so that one's going to be significant, right? But again, this allows me to do two more right away. Because I know that that's significant, I know that that's significant, so these are all significant. That's all. Yes?
Why is it significant? The last
Why
one?
is this significant?
Yeah.
Because of this. If I have a scale, and it's right there. It's right there. What's the precision of that scale? What's the precision of that scale?
Plus or minus 9 or 1.0.
No, not 1.0, just 1. One's place, right? Is everybody all right with that? Hundreds, tens, ones. Two less, right? You all right with that, Morgan? Okay. So what would that reading be? 100.
100.0.
No. If you said 100.0, that means that that scale is to 0.1 or to tenth place. Is that scale to tenth place?
No.
No, it's not. What's the function of that zero?
Exactly.
It means it's right on there, man. Right there. Right? Right there. So doesn't that have a function?
Yes.
So how do you make that significant?
Put a tick over it.
Put a little line over it? You could do that. You could do that. You could absolutely do that. But that's not what we do.
No, I meant those ticks.
The ticks, the check. Yeah. So in other words, but how would you, if I'm visualizing it, if I'm putting it into my data, and I have to report 3 significant figures, how am I going to, for the other scientists replicating my work, how am I going to indicate that that's a significant digit?
It's before the point.
Yeah, but I have to draw in a point. I have to draw it in.
But aren't zeros to the right of the number not significant? They serve as placeholders.
No, but that's not a placeholder. Because it has a function. You see, if it doesn't have a function, then it's just a placeholder. Right? But it has a function. Didn't that zero come from an instrument? Okay, right? Anything that comes from an instrument is significant. If it doesn't come from an instrument, what's it for then? Well, for a placeholder, that's all. Right? Yes or no?
Right.
Yeah. So that's why you use that. So now I've identified this one as significant, this one as significant, so these are all significant. That's all. So instead of saying in number 2, any zero between non-zero numbers are significant, just say zeros between significant figures are significant. That's all. Right? So this is significant. That's all. That's my only point. Okay? Okay. Number 3. We're still working on A, B, C, and D. Did we do? We know what does that bar mean? It's not a Darcy rule, but what does that bar mean? Remember we did that? What does that bar mean? Is what? What does the bar mean? The bar means that zero is significant, right? Didn't we say that? You guys forgot? You didn't forget. You just didn't feel like answering my question. You thought you'd let him answer it and suffer as a result of it. Help the guy out, man, will you? Will? Okay. So where do I use that? Well, what happens if that's the answer there? What's the reading? First of all, this is going to be thousands, so what's going to be the precision? It's going to be tens, right? So that's the answer, correct? 500 is the answer. But are any of those zeros that have a function? Do they?
Yes.
They don't? And so he's going. So I saw the second he changed his mind. No, it doesn't have a. Oh, I get it. Okay, fine. Okay, that was good. I like that. I like that. So if you don't like to say, well, what's the function of the zero? Does it have a function? If you don't like that, if you don't like it, you like it, you don't like it. Okay, that's fine. Don't like it. But what you can say is, precision is tens. This is thousands. 2 less than thousands is 10 thousands, hundreds, wrong way, thousand, hundreds, tens, so 2 less than thousands is tens, so that's tens, so that's significant. That's not, because tens is the lowest, right? So you're going to put a bar over it. If I put a period there, then that's 3 of them. It's only 2. So we did the bar thing. So we're coming into these 6 rules knowing 2 rules, I guess you could say, right? Yes? There's 2 rules that you can't get away from that. We've done them. I showed you. Rules, right? We said that zeros of the bar over are significant. Right? Right?
Between.
Yes! Excellent, Mohammed. Excellent. So far, so good? Yes?
So how would you distinguish between a significant figure with bar over and a recurring figure with bar over?
That's a different reason.
So
Do you ever have? Yeah, it's just a different meaning. Can a word have a different meaning? Can a mathematical symbol have a different meaning? Yeah.
So if you have, for example, 1/3, how would you mark that as recurring?
Well, it depends on the measurement. In other words, if I calculate, all right, that's a great question. All right. The question is, back home, if I have, I do a mathematical calculation and you have that repeating decimal, and so I have 1 divided by 3 equals 0.33 repeating, right? Is that right? Is that what you're asking? All right, so let's erase some of this. So what's the difference? We're going to keep this. So what's the difference between the bar over the 0 and the repeating decimal? Okay, this is a bar we use to indicate significant figures, significance, right, in a number. Okay, and then if I say 1 divided by 3, that's going to equal 0.33, 3 repeating or 3 repeating, right? Whatever the case may be. Correct? That's what your question is. Another one is 2/3, 0.66, right? Correct? Okay. This is the answer to your question. All right. Let's say that you have data, okay? And your data, make it very simple. Your data has, we're doing mass over volume equals density. Okay? Your mass is 1.0 grams. Okay? Yes? Your volume is 3.00 milliliters. Correct? We know the answer is going to be 0.33 repeating, correct? Okay. Well, okay. Yes or no? You with me on this so far? Okay. Now, what does this data tell you about the accuracy of the answer? When you multiply or divide, your answer must have the exact number of significant figures as the value at the least number. So how many significant figures must I have in my answer? 2, right? Are you okay with that? So this is the way I would do it. I would do it mathematically with 1 extra. And then I would round. Okay? All right. So the answer is 0.33. I don't care about repeating. I don't care. I don't care. Because in math class, they have to tell you, well, round to tens place or round to hundreds place or, you know, put the bar over it to tell me it's repeating. I don't care. Why don't I care? Because the rules from Systems International say, do we have that French name again? Didn't you do that, Antoine?
Yeah.
So how do you say Systems International in French?
Système international.
Oh my God, I love it. Can you come up here, please? Just don't get on the camera. Just stay right here and say it really loud, okay? This is like, come on over here. Don't get on camera. Just go right here. That's the microphone's there. Just say it. All right, when I go like this, I'm going to give you a count of 3, and on the number 3, not after 3, on the number 3, you're going to say, I'm not going to say 3, but it's going to be, you know, in your head. Okay. So this is really cool. So this is Systems International. It's a French thing, right? It's and they all call it a French name. Again, last time I spoke French, I had to go to the hospital. Okay, you ready? 1, 2.
Système international.
All right, that was really cool. But that was good. Sorry. Let's do it again, but really loud, okay? Loud, okay? All right, 1, 2.
Système international.
Wow.
Thank you. That was Will, by the way, so, okay. No, that was really cool. So according to that rule, those sets of rules, that's what you do. You put 2 significant figures there. So I don't care about the bar. We don't use the bar for repeating. How many definitions does the word set have? S-E-T. It has over 150 definitions. So I put a bar over a number. Does it bother you that it has more than one meaning? No, of course not, if you think about it. Right? It's called, I don't know, multiple definitions. Right? Yeah? So are we okay to proceed to number 3? This is far longer than I wanted to do.
Could you repeat the rule that you said about when you're rounding, you can only round the number of significant figures to the last one?
Okay. Apart from the fact that it's right in the book, I will repeat it.
Thank you.
You're welcome. The rule says, when multiplying or dividing measurements, the answer must have exactly the same number of significant figures as the measurement with the fewest number. Understood? He thinks I write this down and memorize it. I have no idea what I just said. I make this up as I go along. When multiplying or dividing measurements, your answer must have the same number of significant figures as the measurement with the fewest number of significant figures. Mohammed, put the phone away. Thank you. I know, I know. It's amazing how you can spot that. Understood? Yes or no?
Yes, sir.
When multiplying or dividing measurements, your answer must have, it's not optional, must have the same number of significant figures as the measurement with the fewest number. Understood? Of significant figures, yes? Okay, now, so, 2 significant figures there, 3 there, I must have 2 in my answer. Don't worry about the bar. All right, can we begin? again, can we go back? And we're only on number 2. We've got 6 to get through. Okay, this was supposed to be a quick video. Oh, yes, you had a question.
You
My
said
apologies.
if it's on any scale, the zeros are significant.
If it's from a scale, it's significant, yes.
So they said 300 meters.
Excuse me?
300 meters.
300 meters, what's your... well,
Is it meters on a scale?
the scale is in meters
Yeah.
as opposed
So
to
it's measured from a scale.
liters or whatever. It's just a scale. The units are not the scale. The scale is the scale. You get numbers off the scale. Now, the scale, the numbers could be meters, it could be liters, it could be dynes, it could be ergs, it could be newtons, it could be whatever it is. But the scale is the scale.
You still count the zeros as significant.
What zeros?
300. Because when you put the, like, what, the 100.
Well, if this is 0 and that's 1,000, not all of the zeros in the 1,000 would be significant
So
because the estimated place value is 10, right? So it's not going to be. But if I have 100 gradations between here instead of 10 gradations, so the gradation that's there, the smallest place value that's actually indicated by a graduation is hundreds place. Then 2 less than hundreds place is ones place. So then all of these are significant. Depends on how many graduations are here. If I have no graduations here at all, none, none, then the estimation is hundreds place. So these are not significant. So it depends on the graduations that are there. When I say the word graduation, I'm not talking about what happens after 12th grade. I'm talking about
that makes a lot.
lines, visible lines, graduation. The space between the smallest visible line is called the estimation. Yes? Yes.
It's all in the book, right?
Excuse me?
This is all in the book, right?
Yes.
Yes, in one form or another, but yes. Okay. Have you ever read a textbook before? Have you ever read a textbook before? Is everything in the textbook clearly indicated or sometimes subtly indicated and you might miss something? Does that answer your question? Yeah, it's in the book in one form or another, but depends on how carefully you read it sometimes.
I'm very.
Sometimes, okay, that's fine. That's not a problem. If you're careful, then that's not a problem. Okay? That's why I teach. And it's a reference book, because I like to kind of like, the book is kind of like a, it's kind of like a bush, or, I want to kind of kick it around, see what comes out of it. See what's not, see what's a little bit more subtle, So can we do number 3 yet? Okay, I feel like I'm going to be here till June doing significant figures. Are we? This was supposed to be a short video. Yeah, right there? Okay. Did you do that?
No.
I appreciate
it. Catch it.
Oh, okay. But she was faster. I like that.
She's close.
Quick. She's quick. Oh, well, that is the, oh, yeah, she was, oh, I get it. Now, number 3. Leftmost zeros appearing in front of non-zeros. The book is making things very complicated, but it's not wrong. It's just, okay. Leftmost zeros appearing in front of non-zero digits are not significant. The leftmost zero, I know. Just go with it, okay? It's not nuclear physics. We will do nuclear physics, and this is not it, okay? Leftmost zeros in front of non-zeros. So they're talking about these.
But how would they not be significant if they're telling you?
Yeah, I don't like the rule. Usually significant figure rules identify significant figures. They're not saying, they're trying to identify a negative. That's like, it's difficult. They're placeholders. Can we ignore number 3, and we'll come back to that? Can we ignore that? I really don't like that rule. But it's a good rule, but it's makes things a little bit more complicated. I like to say, here are some rules. If they're not significant after these rules, they're not significant. Okay? All right? But anything that looks like this, where you have nothing to the left, nothing to the left, you know, no non-zero digit to the left. These are just placeholders. Okay? All right. Zeros at the end of a number and to the right of the decimal. That's a good rule. Okay? You ready? What does that mean? What's the end? How do you read a number? Left to right or right to left?
Left to right.
So the end is that way, right?
Yes.
After the decimal point. After the decimal point. After. Yeah! That way. Yes?
Yes.
Yes?
Yes.
You're declaring first down. That way. First down. Got it? You get it? All right, so, and I'm going to give you some advice. You want some advice? You want some advice? Okay. Just do 1 0 that fits that rule. Just one. You don't have to do all, just one. I'm telling you. It's advice. Just do it. Keep it simple. Keep it simple. Keep it simple. Keep it simple. Are you ready? Oh my God. Everything all right? After the decimal point, after. That way. That way. Which way? That way. After. Just one. That's all you got to do, okay? You all right with that? All right. Yes, huh? Which one?
All of them.
What do you mean all? Who said that? Who said that? Who? Blah. You don't have to say all of them. You just say one. I'm just giving you some advice. Keep it simple. One. The front row here is getting it all. They're like stunned. Okay. All right. You're just one. Okay. How about here? Up. That's one. Is that after the decimal point?
No.
No, it's not. Excellent. Up. One. Okay. You all right with that?
Yes.
Yes or no?
Yes. Yes.
Yes or no?
Yes.
Yes or no?
Yes.
Excellent. All right, number 4.
Mr. Darcy,
Yes.
on number 4 with the second most right zero, all two significant, it's between two significant.
This one?
No, it's one lower.
Yeah, we're going to review that in a minute, but you're right. But shh. Okay. All right, here we go. Number 5. We didn't do 4. We did 4. We just did 4.
Was 4. We skipped 3, guys. Keep up, please.
We did 4.
This is
That was 4.
Red, we just did number 4.
Okay.
Okay, that's the rule that says after the decimal, shma, ja, ja, ba. Okay? Okay, number 5. Zeros at the rightmost end of a measurement that lie. Zeros at the rightmost end of a measurement that lie to the left of the understood decimal point are not significant. Here's another one that's identifying non-zero digits. Non-significant digits. Let's read it through. It says, zeros at the rightmost end of a measurement that lie to the left of the understood decimal are not significant if they serve as placeholders to show the magnitude of the number. If such zeros were known measured values, however, they would be significant, right? But so what are they talking about? They're talking about this. They're talking about this situation. Again, I don't like rules, significant figure rules, that identify non-significant digits. Okay, you ready? Here, I go like this. Anything that looks like that, that situation. Anything that looks like that. None of those zeros are significant. Unless they're significant. That's what the book said. I didn't say it, not me. But if they're significant, they're significant. In other words, what does that mean? If such zeros were known measured values, what's anything read from a scale? It's a measured value, right? So why don't they just say that? I don't know. I didn't write the book. The book's a reference. Yes? Understood?
Yeah.
But if it was a known value, in other words, look, you see, 100. If it's read from this scale, this would be read from the scale, so that would be significant because it has a function, remember? It's read from the scale. That's what it says. If such zeros were known measured values, however, they would be significant. Writing the value in scientific notation makes it clear that these zeros are significant or not significant. Clear? In other words, do you understand, given that
Yes.
those zeros are not significant? You understand it? But if I have something like this, they're all significant, right?
Yes.
Yes.
If I have something like this, they're all significant.
Yes.
If I have something like this,
Oh.
these are significant, but that's not, right?
Yes.
You understand that? Yeah, you're shaking your head. Yeah. Now, when you come in on Monday and I ask you that same question, half of you are going to say, I don't understand that. You never taught that. What does that mean? I'm confused. So you got to go home tonight and study and practice because it's a skill. You think that woman who ran so fast never practiced in her life? You practice skills or you lose them. Understood? Yeah, you're going to lose them. Oh, I get it. When I was in high school and I was in math class, I was famous for this. I had other things to do, trust me, in high school. I didn't want to study. I hated it. I'd get up at 3:30 in the morning and go hunting and then come into school late. You think I studied? What, are you kidding me? I would go into school and I'd sit in Algebra 2 and I'd say, yeah, I get this. It's not a problem. It's easy. Okay, fine. Yeah, okay. Come in the next day, take a quiz, get a 0. I forgot. It's a skill they're teaching, and I would follow it. Have you ever done that? In math class, this is really easy. I could do this, right? And you have this great confidence, and it's such confidence that when you get home and you have a lot of fish to fry, you say, I don't want to fry that fish, the math homework, I want to fry this fish. I want to go out and do something fun, okay? You ever hear that expression, other fish to fry?
Oh,
Yeah. Practice a skill. You got to practice, right? Okay.
I actually have a question. What if there's multiple numbers like 34 and then 34,000, for example? Would they still be non-significant without the...
Yeah. Those 3 zeros are not significant. Absolutely. These are not significant.
Okay, what if...
Anytime you have zeros that are not like,
What if it's in between the numbers, like 42?
Yeah, because they're between. Yeah, because that's rule.
Rule 1.
That's rule 2. Zeros appearing between two digits, right? 2 non-zero digits, right? And we extended that rule by saying zeros between. That's significant. That's significant. So that's significant. We extended that rule, right? So if I have this, that's significant, significant, significant. Therefore, these are significant. Remember, we extended that rule. Okay. I have one rule left. May I get to it? Please. Okay? Please. Okay? It says, there are 2 situations in which numbers have an unlimited number of significant figures. Okay? I don't want to do that one. Can we hold off on number 6? Is that okay? Is that okay? Is that okay? Is that okay? Okay, all right, so we're done, really. Number 6 is for something else, and I'm going to go into that in a minute, okay? All right. So now, let's go back and review in case things changed during our reading of the rules, okay? All right, let's see. Let's take them one at a time, right? Do I have to make any changes here?
Yes.
Yeah, significant, significant. Remember the between, right? Done?
Oh, you can ignore the decimal. Okay. Got it.
Yeah, because they're between. Exactly. It's really cool.
Is that a 6 or a 0?
That?
Yeah.
That looks like a 6.
I can't see anything.
That looks like a, well, maybe you want to get your prescription changed. It is in red, my apologies. So sometimes red doesn't come up. If it doesn't come up on the videos, let me know, okay?
Okay.
Do you see it? Or you can always change your seat. If you can't read something, just come up here and look at it. Right?
Okay.
How old are your glasses?
I don't know.
I'm being serious.
I don't know.
I just got these and I can read first aid kit in the back. Can't read them without it.
Surrounded by green, to be honest.
Yeah, so you might want to check your prescription. Okay. Will, can you read that?
Which number? Which number?
Is that a 6?
Now it's a 6.
No.
Okay.
It's
Now
not a 6?
it's a 6, yeah.
Oh, okay.
600.00. That would be some number if it were 000.000. That would be a really. I'd like to see that instrument.
Such zero.
So, okay. Now, so how about here? Are we done? We're done.
Yeah.
Are we done?
Yes.
We're done. Are we done?
Yes.
No.
No, there's that zero. Yeah.
So how many significant figures here?
1, 2, 3.
6,
How many significant figures here?
2,
How many here?
3,
How many here?
5.
5.
What I'll do is this weekend I'll put a significant figure worksheet on Google Docs that will have like 10 zillion practice problems. So you'll be able to, and with the answers, so you can practice them. Okay? I mean, they're easy to practice. Once you get going, and you could like say, and you know what else I'll do? Just hold your second. I will do, you ready? A Mr. Darcy version of how to identify significant figures. Understood?
oh my gosh.
A what version?
A Mr. Darcy version of how to do significant figures. I don't like the way the book does it. I'm sure it's great, it's wonderful. I'm sure he's a very educated person, whoever wrote this. I simply think it's confusing, okay? So I'll do a different version and we can take a vote, all right? Excellent. Now, let's do rule number 6. Yes, question?
Just those 2 zeros, like for B, those 2 zeros after the decimal, if they're not significant, then you can just, for B.
After
B.
that?
B.
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 The second letter.
Those.
Two, if they're not significant, then why are they not significant? Because they're the ones who they give the value of the.
No, they're just holding a place value. That's all they're doing. They're not read from the instrument. In other words, the instrument, can I erase this first?
Okay.
Except for that one, okay? Because that one is going to lead us to the actual purpose of this video that we haven't gotten to yet. This is going to be a long video, okay? You ready? I'm going to erase everything. Okay, erase this. All right, somebody cleaned this with other than water yesterday. Because that shouldn't happen. That shouldn't happen if it's cleaned with water. Okay. What happens is this. What happens, girls? You asked a question, right? Okay. So what happens is this. I have a scale. And let's say the scale is 0.00, I don't know, 0.00,
5.
it's going to take a minute to work on. Right? So what would this measurement be here? What would this measurement be here?
0.0045.
No. What?
Point 0.00450.
You have to put the 0 at the end.
Well, why did you put the 0 on the
It
end?
tells you it's exactly.
Yeah, exactly on that line. Excellent. Why? Because what's the precision of this instrument? This is 10,000ths, right? Is the largest one, right? So here's, you ready? Let's do it. Millions, like a big number, millions, right? hundred thousands, 10,000s, thousands, hundreds, tens, ones. I'm going to get off the, go back here, ones, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, right? So this is going to be 10,000ths, 100,000ths, millions. So you need 1, 2, 3, 4, 5, 6, right?
Yes.
You get it? That's the precision. So your reading must be to 1, 2, 3, 4, 5, 6th place value, correct? So your reading is this.
Wait, you have to add number 0, sir, because that's only
5.
No, because you start with tenths in the decimals.
Oh, let's do this instead, sorry. Let's do that instead. Otherwise it'd be a little confusing. Okay, let's do that instead, okay? I know, that was a little weird, I just switched gears. Okay, so this is thousandths, so it's got to be 10,000ths, 100,000ths. So it's going to be tenths, hundredths, thousandths, 10,000ths, 100,000ths. It's got to be the 5th place value to the right. 1, 2, 3, 4, 5. 5th place value. That 0 means that it's right on the 5. Okay. Yes. I could have put a 0 here. Yes. And it would have been then. It would. Okay. You get it or not?
So then if you don't put the 0 there, does that mean that it's not?
No. The way this is read is fine. I could have made it, it would have been more complicated had I put a 0 here and a 0 here, 15, okay? You didn't need to, understood? Now, I haven't answered your question yet. The answer to the question is, do you see these?
Yes.
That's beyond the measure of the instrument. I can't measure that. I mean, if you say that, well, I can measure this to ones, you don't know what ones is at all. You're not even close to what ones is. You have no idea. You're so far away from it. That these zeros, the only function that these zeros have is to give that thousandths place. So they're not significant. They're not read from the instrument. I know. This isn't a debate, though. I don't care what, you may want to think, well, yeah, it is, but it's not. These zeros are not read, they're just holding place value. That's their only function. Okay, can I push on? Is that okay? Maybe not completely satisfactory, but we'll talk again, maybe do some practice. Now, let's say this. This is rule number 6. Are you ready? This is rule number 6. Are you ready?
Ready.
Okay. There are 2 situations that have an unlimited number of significant figures. The first involves counting. A number that is counted is exact. Okay? 1, 2. 2. Buckle my shoe.
MLG counting.
I heard you. Because I expected it. Okay? 2. That number 2, how many significant figures are there? Infinite. Infinite. It's encapsulated. I can put as many as I want. Clear? So if I have 2 measurements and one measurement is counted, that's not going to reduce the number of significant figures. So if I have 2 times 304.00, how many significant figures are in my answer? The answer is mathematically, it would be 6, 0, 8. How many significant figures? This is counted. How many significant figures are in my answer? 1? Would it be 600? Is that what it is? This has an unlimited, this has an infinite number of significant figures because it's counted. Therefore, the minimum number of significant figures is 5. So the answer would be 0.00. This looks like one significant figure, but remember, it's counted. So when you do your experiment, you have to understand that it's counted. I counted out 5 beans that I took the mass of.
So how does she get 5?
What's the average mass of the bean? So let's say the beans are 10.0 grams divided by 2, divided by, how many beans did I say? 5. Divided by 5. 5 beans, correct? So it's going to be 2 grams, right? Because that 5 is 1 significant figure, you're thinking? So 10, 3 significant figures divided by 1? No, because this is counted. So it's going to be 2.00. You get it? You understand? When you multiply or divide measurements, your answer must have the same number of significant figures as the measurement with the fewest number. Edwin, do you understand that? That's a statement. That's a fact. Jack, you can't get away from it. Is there any problem with that? It's a simple rule. Don't make this difficult. Understood? Yes or no? Yes?
Yes.
Okay, said the wolf to the frog just before the wolf ate the frog. Don't make this difficult. But do you understand? Easy? Okay. So here I have 2 measurements. I have 2 measurements, Edwin. This measurement and this measurement. Okay? How many significant figures are there, Edwin?
There are 2.
How many significant figures are there, Edwin?
3.
There are 3. Remember, the 0, yes, end, after, that way, first down, that one, that one, that one, that one, that one, there you go, that's it, okay, you got it? Yes, you get it? So there are 3, right, Edwin? Yes or no?
Yes.
How many significant figures are there? It's 5. I said to you, if something is counted, it has an infinite number of significant figures.
Well, what does that mean?
That means that I counted out 5 marbles. 1, 2, 3, 4, 5. There are 5 marbles there, right? 5 marbles. Yes? 1, 2, 3, 4. Oh! 5. There are 5 there. That's what I mean by counting. Okay? How many books are on your desk? Count the number of books on your desk. Can you count?
2.
Excellent. Well done. With the onset of computers, the last great mathematical virtue is counting. So if you can't count, drop chemistry and take cooking.
But you have to be counting for.
You got to be able to count. Yes? You've got to be able to count, right? The basis of finding an average. If I found the average height of all the students in this room and I used this really complex instrumentation which generated 100 significant figures in length for each person, and I divide by 20 students. There's 20 students in here. Well, all right, 19 students in here. We have somebody absent, okay? What do? I divide it by 19. So how many significant figures are in my answer? 19? No, because that 19 is a count, so it's an infinite number, as many as you want. In other words, it's not going to restrict the number of significant figures. The measurement with the fewest number of significant figures is going to be that, because that's infinite. So that's going to be it. So that's the first situation. The second situation involves a defined quantity found within a system of measurement. Like, how many seconds are in a minute? How many seconds are in a minute? How many? 60, okay. 60 seconds, 1 minute. Now, I'm not measuring the time. In other words, I don't have a stopwatch and say, well, it's exactly 60 seconds. That's a little weird. How to come up exactly 60 seconds? I've never seen that. Can you possibly get a stopwatch and try to press play and then get exactly 60? That's